Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x is equal to 7. So, for my left-hand side, I'm going to first start by factoring out 5 to the power of x. So I get 5 to the power of x times 1 plus 1 is equal to 7, because 5 to the power of x divided by 5 to the power of x is 1. Now, 1 plus 1, this is equal to 2. So I get 5 to the power of x times 2 is equal to 7. Now from here, I want to isolate 5 to the power of x because that's where our variable x is located. So to do that, we have to get rid of this 2 here by dividing both sides by 2. So then these two 2's cancel out, and I'll be left with 5 to the power of x is equal to 7 over 2. Now from here, I'm going to take the log on both sides. So I get log 5 to the power of x is equal to log 7 over 2. And if I have something in the form log a to the power of b, I can move this exponent b to the front. So this can equal b times log a. So in this case, I have log 5 to the power of x, and I can move x to the front. So I get x times log 5 is equal to log 7 over 2. And another important property of logarithms is that if I have something in the form log a over b, this is the same thing as log a minus log b. So our numerator, log of the numerator, minus log of the denominator. And while we're at it, another important property of exponents is that if I have something in the form log a times b, this is equal to log a plus log b. So notice how these two are similar. Division, it results in subtraction, and multiplication results in addition. So now going back to my problem, we're going to use this property for log 7 over 2. So I get x times log 5 is equal to log 7 minus log 2. Now we want to isolate x, so I'm going to divide both sides by log 5. So these two cancel out, and I get x is equal to log 7 minus log 2 over log 5. Now from here, I'm going to plug in the values of log 7, log 2, and log 5. So to start, log 7 is equal to approximately 0.8451. Log 2 is equal to approximately 0.3010. And finally, log 5, this is equal to approximately 0.6990. So, if I plug these back into my original equation here, I get x is equal to 0.8451 minus 0.3010 over 0.6990. And this is equal to 0.5441 over 0.6990, which is equal to 0.7784. So x is approximately equal to 0.7784, and you can try plugging this back into the original equation and see what you get.